Good morning, sixth graders. We have day 2 of ratios, rates, unit rates, and proportions. So yesterday, you might remember, we had a very similar looking sheet of notes, and it was all about ratios. And I had highlighted ratios. We talked about being a comparison of two quantities using division, and the focus was on Skittles. I had different problems with, I think it was red and green Skittles, and we made a whole bunch of different ratios. But because we were always talking about Skittles, they were just that, only ratios. And today we have actually different units, which is why we're going to be talking about a rate. Now, it's still a ratio, but it's just a special ratio where the two terms have different units. And what we're talking about there is things like miles and hours. So they're around us all day. You've seen speed limit signs that say miles per hour. You talk about cost per pound. All right. We see these ratios that have different units all around us, and it can be really helpful in making predictions and comparisons. And the most helpful kind in making comparisons is a unit rate. And all that means is we divide out the ratio. We divide out, because remember, all ratios are all fractions are really a division problem in disguise. So all we have to do is divide it out to get the unit rate. Okay, so I shared this sheet of notes with you. I'll read through some of it right now. For example, if your family were on driving on a long road trip and made it 120 miles in 2 hours, that's a ratio, 120 to 2. And when we have different units on there, like 120 miles in 2 hours, so like yesterday again, this was Skittles and Skittles. It was maybe red Skittles and all Skittles, or green Skittles and all Skittles, or green Skittles and red Skittles, right? Because we were always talking in Skittles, it was just a ratio. But now we have 120 miles in 2 hours. That's why we can consider it today a rate. We can make conversions with that rate. We could say, how long is this trip going to be? If we know it's 360 miles, then we just keep adding on. Well, 120 times 3 is 360. So just like that equivalent fraction, 2 times 3 is 6. So you basically counted this rate 3 times. Okay? And then keeping that same ratio, an equivalent ratio, right? That tells me it'll take us 6 hours to make that trip. But to make those comparisons even easier, those predictions even easier sometimes, we can find a unit rate. Okay? And all we have to do, again, to do that is to divide out 120 over 2 is just a division problem. 120 divided by 2 is 60. And if you want to think of it as an equivalent fraction, it's like you're doing that to both the top and bottom. You're doing 120 divided by 2 and 2 divided by 2. And you get 1, right? So you're keeping that equivalent fraction idea. That's another way to think about it. But really all we're doing is doing 120 divided by 2, and we have 60. Now, in this example, they all came out to be whole numbers. Okay? But they're not always going to be whole numbers. Oh, before I do that, let's talk about this word here, per. The unit rate then, which is right here, remember we said a unit rate has a denominator of 1, so we have 1 hour there. The unit rate then we say is 60 miles per hour. So you've heard that quite a bit, and I mentioned that a minute ago, like cost per pound, or you're saying like how much is it per apple, or how much is it to buy all these t-shirts, so how much is it per one shirt. That word per then tells us that we're now dealing with that unit rate, 60 miles per hour, and that's where you see the MPH on a speed limit sign or on the speedometer on the dashboard of your parents' car, right? So 60 miles per hour, and that's what that's telling us, is that for every 60 miles we're going, per every 1 hour I should say, we're going 60 miles. Okay, but it don't always come out to be an exact whole number. That one was 60 miles per hour. Here's an example where we're making a comparison. Imagine you're at the grocery store helping shop for food. Who doesn't love some corn dogs, right? We got these mini corn dogs, and I looked these up yesterday on like Woodman's site. So these are real prices. I found a package of corn dogs that was 29.3 ounces for $4.79. So I expressed that as a ratio, and because it's dollars on the top and ounces on the bottom, that's a rate. Now, could you do 29.3 ounces over $4.79? Yes, but then when you divide it out, you'd be finding how many corn dogs you get per dollar, which is also very useful. So long as both of your rates are set up the same way, then you can make that comparison. The way that I did it with the dollars on top and the ounces on bottom, we're going to be finding the cost per ounce, which is the more common way that that rates are expressed. Excuse me. When you're making comparisons about money, is you find out how much it is per the unit that you're buying, as opposed to finding how many you get per dollar. If you're finding how many you get per dollar, then you're looking for a higher number, right? But because I'm finding out how much they cost per ounce, then I'm looking for, excuse me, frog in my throat there. And then I'm looking for the lower number, right? I don't want to pay more for the same amount of corn dogs, which that's why we make it this common denominator of one ounce. Then I can see very clearly how many I'd have, how much I'd have to pay per that 1 ounce. So if you were only looking at their rates, those would be kind of hard to compare. But all I have to do is divide it out. And to find this unit rate, again, all we need to do is divide the numerator by the denominator. So all I did was type in a calculator, 4.79 divided by 29.3. And I got a fraction. I'm sorry, it was a decimal. It was 0.16, where was it? I wrote it down here. 0.16348, and this one went on and on and on and on. Well, I just rounded it because we're dealing with money. So I rounded it to the hundredths. I cut it off after the 0.16, and I said that's 16 cents, because the 3 here didn't make it any more. So that was 16 cents per ounce for that first option A, we'll call it. Then I did the same thing for this second deal here, 56 ounces for $10.99. I did $10.99 divided by 56 ounces. This one wasn't quite as long of a decimal. It actually terminated after 5 spaces here, but I still am dealing in money. So I took the 0.196 and I rounded it to 20 cents, because this 6 in the thousandth place would tell me to make this 9 rounded up, or the 19 really then becomes a 20, right? So that's 20 cents. And if I'm looking at that, I'm paying, again, 20 cents per 1 ounce with this second deal, where the first deal I'd only be paying 16 cents per 1 ounce. So that means the first option is the better value for my money. I'm going to get more corn dog for the same amount of money, or if you're looking at it like per ounce, you're paying less for the same amount of corn dogs. This option of the better value is commonly referred to as the better buy. So you're going to see that on assignments, not only that I might give you, or that like tests that we might have in our class. You're going to see that on like forward exams and MAPS tests and Freckle and ST Math. That's a common math phrase, the better buy. Which one is the better buy? I mean, it means which one would give you more for your money, or if you bought the same amount, which one would cost less. So again, that's a quick overview on rates and unit rates. Again, this top part is exactly the same as the sheet that we gave you yesterday for ratios, but today the focus was rate and unit rate, which is why I made the background a different color. And we might talk a little bit more about rates and unit rates before we get on to proportions, but when we start talking proportions, we'll do the same thing. The top definitions are very important. They're going to stay with us, and then the rest of the notes here might change up a little bit, okay? Let's make sure we're still working hard on Freckle and ST Math, reaching out with questions. I'll see some of you for a numeracy routine later today. And then enjoy the rest of your day. Hopefully the weather's supposed to turn here. We'll get back outside, right?